Welcome back again. The other variable type we wanted to talk about is arrays. So with an array, simply what it is it's reserving a block in memory for a repeated number of variables. So here what we've got is we've got a character called y, and it actually has this additional syntax with a bracket, and that's saying it's an array. So it's not actually just a single character, it's actually an array of 5 characters. So what it does is it just reserves a block in memory, says, hey, make me enough space in memory for 5 characters. It actually guarantees that they're a continuous block in memory as well. And then that way you can reference the 0 item in the array, the first, second, third, and fourth. So they actually are 0 indexed. So you could actually reference them for the numbers 0 through 4, which confuses some people because, hey, didn't I say there were 5? It's like, yeah, you said there were 5, but there's no 5th one because they're 0 based. They are quite useful. They make life easy to reference. So if you've got a piece of data that really does belong together, to think of it together, it goes well into an array. And if you wanted to pull things out, pulling things out is quite easy. So here's the syntax for pulling out the 0th element in the array. So this would just pull out the number, my char would become 2 in that first case because the 0th element is right there. And let's say if this was my char right here, it would just copy in the 2. If you pulled out 4, that would be the bottom one. So the only thing that would change is that would become a 1. Likewise, you can reference it the other way. It's so simple I didn't even put it on here. So if you wanted to set something, so if you wanted to set whatever was in the 3rd spot to 7, you could do that. And you could figure out, which one is the 3rd spot. The 3rd spot, index 3, I should say, is right there, and so to make that a 1, 1, 1. So that's an array, pretty simple. The only place that arrays get complex at all is in the syntax and exactly how you create them. So there are actually 2 steps when you make an array. There's the declaration, so like you're declaring that it exists. What the declaration does is it reserves spots in memory. So you declare and then you define. Now, if you do them separate, people find that pretty easy in their mind, right? So you declare, that gives you space in memory, and then you define kind of one at a time what goes in there. There are, of course, shorthands. There's all these shorthands. One way you can do it is you can declare and define in one step, and what this does is this says, put in a 1, a 2, a 3, a 4, and a 5. It also, since you're doing it all in one step, you don't have to say the size. It will infer the size based on how many you filled it in with. So this is the generic way to fill an array. So declare and define in one step. You'll probably also see plenty special things you can do with character arrays. In C, officially they're called character arrays and not strings, but really one is the same. One is the same, right? And so if you declare this character array Bob, what it'll do is it'll put a value for capital B, a value for little o, a value for little b, and then there'll actually be one more bonus character called the null character that gets in there. So what this does is it's an array. It actually is of size 4. You did not have to put it in because it figured out that it was size 4 because you had 3 characters in the null terminator. But that's another special way you can declare and define an array all in one, and it's using ASCII. Let's go ahead and talk a little bit more about ASCII. So arrays and strings, they kind of go hand in hand. ASCII, all ASCII is, it is a way to have a symbol represent a number. So it's kind of like its own number system, right? So like when we learned about hex, we said, hey, this symbol A represents 10. The symbol B represents 11. ASCII is kind of the same way, but even more extreme, right? And so the ASCII character A starts right there. So the ASCII character A represents 65. And the way you write it is you write it with single quotes. So, I mean, obviously, you learned about the prefix 0b, the prefix 0x. With characters, you put them in single quotes. Whenever you see these single quotes, there will only ever be one character inside of it. So you will never use single quotes with like multiple things. Like, you can type it, but it's meaningless. So anytime you see these single quotes, it means, you know, use the ASCII conversion system. And no matter what symbol you see, so let's say you see the lowercase a symbol. The lowercase a symbol, it just refers to another number. It refers to 97. So if you were to say, you know, like an integer is equal to a, that would be the exact same, sorry, I should have said integer x. That would be the exact same as saying integer x is equal to 97. They are completely identical to a computer, right? I mean, it's just a symbol that represents a number. Most people are okay with that. The one that gets you is that the symbol, this one I love. So the symbol, the ASCII character 0, that is also a symbol, but it doesn't mean 0 anymore. It means 48. Yeah, not kidding. So that's just how you convert from an ASCII to integer. You have to use this table. The places in the table that we'll use the most are, of course, the numbers, the uppercase letters, and the lowercase letters, right? So there's kind of like these three blocks that we'll actually use quite a bit in the course. It turns out ASCII ends up being useful in a lot of ways. So there's kind of some ASCII tricks that I remember. So for example, I just know that if I wanted to convert like the number 3 into ASCII, so if I wanted the ASCII for 3, it would just be x plus 48, right? So you see that plus 48 all the time, just to convert something from its integer form up into its ASCII equivalent. So let's look at some more details. So here's an example just to kind of point out that they're all the same. So here we've got uppercase B, and you know, I don't have these things memorized. I've got to go look. What's uppercase B? Uppercase B is this number right here. So it is 66, which you could also write in hexadecimal as 0x42, right? So now that we know it's 66, so this statement right here is really just saying y is equal to 66. If you wanted to print y as a decimal, it would just say 66. If you wanted to print y, this is kind of interesting. Instead of saying %d, you say %x, and then I put a %x in front of it here just so you can see it. You can see that you could actually print it as 42, and you can see that these are the same thing. You could keep going. If you wanted to print it in binary, it's %b, so it gets printed in binary, kind of ugly. And if you wanted to print it out in ASCII, that's a %c. So if you wanted to display something in ASCII, you say %c, and it'll show you what the ASCII character is, which is b. So doesn't matter which system you use, decimal, binary, hexadecimal, or ASCII, they all get stored as ones and zeros no matter what. And they're just different ways of saying the same thing. So here's a couple more examples just to kind of point things out. Arrays, you know, this T will get converted into a number, will get stored into an array. This is a declaration and definition all at the same time. This is using the generic syntax on top. This generic syntax, you can see we manually added this null character. So it's this, oh, I think I made the direction of that slash wrong earlier. It's a, what is that, a forward slash? No, that's a backslash because it's coming back. So \0 is how you finish character arrays if you want them to kind of be strings, right? So we'll continue to talk about this, but this null character at the end, that's kind of how the computer knows, hey, here's the end of this word, or here's the end of this string, right? I shouldn't say word because this is 2 words. So the null character, this line right here adds it for you. So it turns out these top 2 lines are completely identical. They are exactly the same. Then I left you a little challenge in here. So this is another string, which I've defined in a very, very different way. I can tell it's a string because I can see that it ends with the null character. Instead of defining things with ASCII, like I did up here, I define them with, well, here I use decimal, there I used ASCII, that one's hexadecimal, that one's binary. See if you can figure up what this string is. So I could have also just, made it as a string. When you get it right, you'll know. So I just kind of leave it up to you to try to do that. And then just to mention it, you can also print things out as the entire string. That's a %S symbol. So this line right here would just print toy boat. And then this line right here, oh, I don't want to give away what it is. All right, fine. It would print ABCD. And then, of course, I mentioned at the bottom the null character. Cool, so that's kind of everything that I wanted to tell you today about arrays. They're blocks of memory space for repeated variables of the same type. They don't have to be chars. They can be ints, they can be longs. It'll just have bigger blocks. The way that arrays get used a lot is the char arrays get used to make, character arrays, which are strings. So that's the way arrays get used quite a bit. All right, that's kind of it. Oh, I do have one more. I wanted to mention that there are more types. There's something called pointers, which we're not going to talk about in this class, structs, enums or enums, however you want to say it, and a thing called typedef. If you have questions about them, I use them plenty in my life. Turns out that in this class, nobody ever needs them for their projects, so we are not going to talk about them. If you want to look them up, though, C has been around for 40 years. I assure you there's a lot of great websites if you want to learn about these details. All right, that's it, and I'll see you next time. Bye.